The ocean is a truly vast and wondrous place. It covers most of our planet Earth. Within its depths, an incredible variety of life thrives. Fish, in particular, show an amazing diversity. There are so many different kinds of fish. They come in all shapes, all sizes, and all colors imaginable. Some are tiny, no bigger than your fingernail. Others are enormous, larger than a small boat. This incredible range of fish species makes the ocean a constantly surprising realm. We are always learning new things about them and the way they live their lives. These fish inhabit every corner of the ocean. They live from the warm, sunlit surface waters to the cold, dark abyss. Some fish prefer the shallow coastal areas. Others are found in the open ocean, far from any land. Many make their homes in vibrant coral reefs. Still others dwell in the crushing pressures of the deep sea. Each type of fish has perfectly adapted to its specific environment. This adaptation is key to their survival. It allows them to find food, avoid predators, and reproduce successfully. The story of ocean fish is a story of remarkable adaptation and resilience in an ever-changing world. Think about the sheer number of fish species. Scientists believe there could be tens of thousands of different kinds. Each one has its own unique characteristics and behaviors. Some fish swim in large schools for protection. This helps them confuse predators and find mates more easily. Other fish are solitary creatures, preferring to live and hunt alone. Some fish are herbivores, eating only plants like algae. Many are carnivores, preying on other smaller fish or marine animals. And some are omnivores, eating both plants and animals. This variety in diet also reflects their adaptation to different food sources available in their habitats. The study of these ocean dwellers is a continuous journey of discovery. New species are still being found, especially in the less explored parts of the ocean like the deep sea. Understanding the diversity of fish helps us appreciate the complexity of marine ecosystems. It also highlights the importance of protecting these fragile environments. Every fish, no matter how small or strange-looking, plays a role in the health of the ocean. Their survival is interconnected with the survival of many other marine organisms and ultimately with our own well-being as inhabitants of this blue planet. The ocean's fish are a treasure we must strive to understand and protect. Coral reefs are like bustling cities under the sea. They are found in warm, shallow, and clear ocean waters. These waters allow sunlight to reach the corals. Sunlight is very important for the tiny algae that live inside the corals. These algae, called zooxanthellae, have a special partnership with the corals. The algae produce food through photosynthesis, using sunlight. They share this food with the coral polyps. In return, the corals provide a safe place for the algae to live. This relationship is the foundation of the entire reef ecosystem, making it vibrant and full of life. The structure of a coral reef is complex and beautiful. It is built by tiny animals called coral polyps. These polyps create hard skeletons made of calcium carbonate. Over many years, these skeletons build up. They form the intricate structures we know as reefs. These structures provide homes and hiding places for countless marine creatures. You can find caves, tunnels, and ledges within the reef. These features offer protection from predators and strong currents. The reef is a true sanctuary, providing shelter and sustenance to a vast array of marine life, making it one of the most biodiverse habitats on Earth. Life in the coral reef is a kaleidoscope of activity. Brightly colored fish dart in and out of the corals. Crabs and shrimp scuttle along the reef's surface. Sea turtles gently swim by, sometimes stopping to rest. The sheer number of different species is astounding. Scientists estimate that about 25% of all marine life depends on coral reefs at some point in their existence. This makes reefs incredibly important for the overall health of the ocean. They are like the rainforests of the sea, packed with an extraordinary concentration of life and biological processes that are vital for the planet. The sunlight that bathes these shallow waters is a key ingredient. It not only fuels the coral algae symbiosis, but also supports other photosynthetic organisms like seaweed. These primary producers form the base of the food web in the reef. Herbivorous fish graze on the algae, keeping it in check. Carnivorous fish then prey on the herbivores and smaller fish. This intricate web of life is finely balanced. The clarity of the water is also crucial, allowing sunlight to penetrate deeply. Healthy coral reefs are a sign of a healthy ocean, reflecting the delicate balance required to sustain such rich biodiversity. Among the many inhabitants of the coral reef, the clownfish is one of the most recognizable. These small, brightly colored fish are famous for their striking appearance. They usually have vibrant orange bodies with bold white stripes. These stripes are often outlined in black, making them stand out. Clownfish are also known by another name, anemone fish. This name hints at their very special relationship with sea anemones. They are a joyful sight, darting amongst the tentacles of their host anemones. Their playful movements and vivid colors add a splash of brilliance to the already stunning reef environment. Clownfish are relatively small, usually growing to about 3 to 4 inches in length. This small size makes them vulnerable to larger predatory fish in the open reef. However, they have found a clever way to protect themselves. They live within the stinging tentacles of sea anemones. Most other fish would be harmed or even killed by the anemone's stings, but clownfish have a special mucus coating on their skin. This coating protects them from the anemone's nematocysts, which are tiny stinging cells. This unique adaptation allows them to live safely where few other fish can venture, creating a secure home base. You can find clownfish in the warmer waters of the Indian and Pacific Oceans. They're typically seen in shallow lagoons or sheltered reefs. These areas provide the calm conditions that sea anemones prefer. A clownfish family, which often consists of a large breeding female, a smaller breeding male, and several smaller non-breeding males, will usually inhabit a single anemone. The clownfish rarely stray far from their host. Their entire life revolves around this protective anemone. It is their shelter, their nesting site, and a place where they can find some food particles left over from the anemone's meals. The vibrant colors of the clownfish are not just for show. While they make the fish attractive to us, they may also serve a purpose in their natural habitat. Their bold patterns could act as a signal to other clownfish, helping with species recognition or territory defense, or perhaps their brightness contrasts so much with the anemone that it confuses potential predators. Whatever the precise reasons, their appearance is undeniably part of their charm and their successful strategy for life on the bustling coral reef. They are a perfect example of how reef creatures have evolved specific traits to thrive in this competitive environment. The relationship between the clownfish and the sea anemone is a classic example of symbiosis. More specifically, it is a form of mutualism. This means that both partners benefit from living together. The clownfish gains significant protection from predators by living within the anemone's stinging tentacles. Few predators are brave enough to risk being stung by the anemone to catch a small clownfish. This safe haven is crucial for the clownfish's survival, especially for the young and vulnerable members of the group. The anemone provides a nearly impenetrable fortress for its small, colorful tenants. In return for this protection, the clownfish provides several benefits to the anemone. Clownfish are known to be quite active. They swim around the anemone, and this movement helps to aerate the water around the anemone's tentacles. This increased water circulation brings more oxygen to the anemone. Clownfish also help keep the anemone clean. They may eat algae and other debris that could otherwise smother the anemone. Some studies suggest that clownfish may even lure other small fish towards the anemone, providing it with food. The clownfish essentially acts as a helpful housekeeper and perhaps even a food provider. Furthermore, clownfish can be fiercely protective of their host anemone. They will bravely defend it against certain types of fish that might try to eat the anemone's tentacles, like butterfly fish. Despite their small size, clownfish will charge at these intruders, nipping at them to drive them away. This defensive behavior helps ensure the anemone remains healthy and unharmed. It's quite a sight to see such a small fish exhibiting such bold behavior to protect its much larger partner. This dedication underscores the importance of the anemone to the clownfish's way of life. This partnership is a delicate balance, developed over long periods of evolution. The clownfish gradually acclimates to its host anemone, slowly building up its protective mucus layer. Not all anemone species are suitable hosts for all clownfish species. There is a degree of specificity in their pairings. This intricate relationship highlights the interconnectedness of life on the coral reef. It shows how different species can evolve to depend on each other for survival and success. The clownfish and anemone are a beautiful illustration of cooperation in the natural world, a testament to nature's ingenuity in fostering mutually beneficial bonds. Section 5. Descending into darkness, the mysterious deep sea. Beyond the sunlit coral reefs lies a completely different world, the deep sea. This vast realm begins where sunlight can no longer penetrate effectively, typically below 200 meters. As you go deeper, the light fades completely, plunging the environment into perpetual darkness. The deep sea is the largest habitat on Earth, yet it remains one of the least explored. It is a place of extremes. The water is incredibly cold, often just a few degrees above freezing. The pressure is immense, increasing dramatically with depth. For every 10 meters you descend, the pressure increases by about 1 atmosphere. Life in the deep sea faces enormous challenges. The absence of sunlight means there are no plants to form the base of the food web through photosynthesis. Food is scarce here. Most of it comes from marine snow, which is a continuous shower of organic detritus. This detritus falls from the upper layers of the ocean. It includes dead plankton, fecal pellets, and other biological debris. Finding enough to eat in this vast dark space is a constant struggle for deep-sea creatures. They have evolved remarkable ways to conserve energy and to make the most of any meal they can find. The creatures that inhabit the deep sea are often bizarre and fascinating. They have developed unique adaptations to survive in such harsh conditions. Many deep-sea organisms are bioluminescent. This means they can produce their own light. This light can be used for various purposes. It can help them attract prey in the darkness. It can be used to startle predators. It can also help them find mates in the pitch-black environment. The patterns and colors of bioluminescence are incredibly diverse, creating fleeting, magical light shows in the otherwise unlit depths of the ocean. Exploring the deep sea is a difficult and expensive endeavor. It requires specialized submersibles capable of withstanding the crushing pressures. Because of these challenges, much of the deep ocean remains a mystery. Scientists are constantly discovering new species and learning more about how life can exist in such extreme conditions. Each discovery provides new insights into the adaptability of life and the incredible biodiversity our planet holds. The deep sea is a frontier of exploration, holding secrets that could change our understanding of biology and the limits of life on Earth. It is a world of darkness, pressure, and strange beauty. Section 6, Lurking Lights, the Enigmatic Anglerfish. One of the most iconic inhabitants of the deep sea is the anglerfish. This creature is perfectly adapted to life in the dark, cold depths. Anglerfish are named for their unique method of hunting. Most female anglerfish have a long, fleshy lure that extends from their head. This lure, called an esker, often dangles in front of their enormous mouths. The tip of the esker in many species is bioluminescent. It glows with a faint, eerie light. This light is produced by symbiotic bacteria that live within the lure. The anglerfish can wiggle this lure to make it look like a small, tasty morsel. Unsuspecting smaller fish or crustaceans are attracted to this glowing, moving bait. They swim closer to investigate, thinking they have found a meal. When the prey gets close enough, the anglerfish opens its huge mouth. It snaps shut with incredible speed, engulfing the unfortunate victim. Anglerfish have large, sharp teeth that point inwards. This ensures that once prey is caught, it cannot easily escape. Their mouths and stomachs are also highly distensible. This means they can expand greatly, allowing some anglerfish to swallow prey even larger than themselves. This ability is crucial in an environment where meals are few and far between. The appearance of the anglerfish is often described as grotesque or monstrous. They typically have soft, flabby bodies and dark coloration ranging from dark grey to black. This dark color helps them blend into the pitch-black surroundings, making them even harder for prey to spot. Their skin lacks scales, and their bones are often light and flexible. These features are adaptations to the high-pressure environment of the deep sea. They don't need strong, rigid skeletons in a place where buoyancy is less of an issue and energy conservation is paramount. Their overall form is a testament to survival in extreme conditions. A particularly fascinating aspect of some anglerfish species is their unusual reproductive strategy. Male anglerfish are tiny compared to the females. When a male finds a female, he bites into her skin. He then fuses with her body, becoming a permanent parasite. The male loses his eyes and most of his internal organs, except for his testes. He receives all his nutrients from the female's bloodstream. In return, he provides sperm whenever the female is ready to reproduce. This bizarre arrangement ensures that when a female is ready to spawn, a mate is always available, a crucial adaptation in the vast, sparsely populated deep sea. Section 7. Masters of Disguise and Swift Swimmers. Flounder and Tuna. Not all ocean fish live in the extremes of coral reefs or the deep sea. Many thrive in other varied marine environments, showcasing a wide array of adaptations. The flounder, for instance, is a master of camouflage. This flatfish lives on the sandy or muddy bottoms of the ocean. As a larva, a flounder looks like a typical fish with one eye on each side of its head. However, as it matures, a remarkable transformation occurs. One eye migrates to the other side of its head, so both eyes are on the same side. This allows the flounder to lie flat on the seabed with both eyes looking upwards, watching for prey and predators. Flounders have an incredible ability to change their skin color and pattern. They can match the texture and hues of the surrounding seabed almost perfectly. This makes them nearly invisible to unsuspecting small fish, shrimp or crabs that they prey upon. It also helps them avoid being detected by larger predators like sharks or seals. When a flounder settles on the bottom, it will often flick sand or mud over its body. This further enhances its camouflage, leaving only its eyes exposed. This skill in disguise is a crucial survival tactic developed to an art form by these fascinating flatfish. In stark contrast to the stationary camouflage flounder, the tuna is a marvel of speed and endurance. Tuna are built for life in the open ocean, constantly on the move. They have sleek, torpedo-shaped bodies that are highly streamlined. This shape minimizes water resistance, allowing them to swim at incredible speeds for long distances. Some species of tuna can reach speeds of over 70 kilometers per hour. They are powerful swimmers, with strong muscles and a crescent-shaped tail fin that provides maximum thrust. This speed is essential for hunting fast-moving prey like smaller fish and squid. Tuna also possess a remarkable physiological adaptation. They are partially warm-blooded. Unlike most fish, which are cold-blooded and have body temperatures similar to the surrounding water, tuna can maintain a body temperature higher than the ambient water. This is achieved through a specialized system of blood vessels called the rete mirabile, or wonderful net. This system allows them to conserve the heat generated by their active muscles. Having warmer muscles allows them to function more efficiently, especially in colder waters. This gives them a significant advantage as powerful predators in diverse oceanic regions, enabling them to pursue prey across vast temperature gradients. Section 8. A symphony of survival, unique fish adaptations. Let's revisit our 4 fascinating fish to appreciate their unique adaptations more closely. The clownfish, a jewel of the coral reef, showcases a brilliant adaptation through its symbiosis with sea anemones. Its special mucus coating is a biological marvel, rendering it immune to the anemone's potent stings. This immunity allows it to live in a protective fortress, safe from most predators. In return, the clownfish's activity aerates the anemone, and it may even defend its host. This mutualistic relationship is a testament to coevolution, where two species develop traits that benefit each other, ensuring their shared success in a competitive environment. The clownfish's bright colors might also play a role in communication or predator confusion. The tuna, an athlete of the open ocean, is a paragon of hydrodynamic design and physiological efficiency. Its torpedo-shaped body, powerful muscles and specialized tail fin are all honed for high-speed swimming and sustained endurance. This allows tuna to chase down fast prey and undertake long migrations across entire ocean basins. Perhaps its most remarkable adaptation is its ability to maintain a higher body temperature than the surrounding water. This endothermic capability, rare among fish, keeps its muscles warm and efficient, providing a crucial edge in both cold and warm waters. Tuna are truly built for a life of perpetual motion and predation. The flounder offers a masterclass in camouflage and patience. Its flattened body and the extraordinary migration of one eye during its development are key to its bottom-dwelling lifestyle. Lying flat on the seabed with both eyes facing upwards, it can ambush prey and evade predators with remarkable effectiveness. The flounder's ability to change its skin color and pattern to perfectly match its surroundings is an incredible feat of biological engineering. This dynamic camouflage, combined with its habit of burying itself partially in the sediment, makes it virtually undetectable. The flounder's survival depends heavily on its ability to become one with its environment. a silent hunter waiting for the opportune moment. Finally, the anglerfish from the deep sea is a creature of haunting ingenuity. Living in perpetual darkness where food is scarce, its bioluminescent lure is a vital tool for survival. This glowing bait, produced by symbiotic bacteria, dangles enticingly to attract unsuspecting prey into its massive tooth-filled jaws. Its dark, flabby body and minimal skeleton are adaptations to the crushing pressures and low-energy environment of the abyss. The extreme sexual dimorphism, where tiny males fuse to the much larger females, is a bizarre yet effective solution to the challenge of finding mates in the vast emptiness of the deep ocean. Each of these fish demonstrates nature's incredible power to shape life for survival. Section 9. The Ocean's Grand Tapestry, a world of wonder. The clownfish in its sunlit anemone, the tuna streaking through the open blue, the flounder hidden on the sandy floor, and the anglerfish with its ghostly lure in the abyss. These creatures are but a tiny glimpse into the ocean's immense biodiversity. Each one tells a story of evolution, of challenges met and overcome through incredible adaptations. The vibrant colors of reef fish are not just beautiful. They serve purposes like communication, camouflage, or warnings. The sleek bodies of fast swimmers and the flattened forms of bottom dwellers are perfectly suited to their lifestyles and the physical forces of their watery world. From the brightest shallows to the darkest depths, fish have conquered every imaginable marine habitat. They have developed ways to breathe, see, hunt, and reproduce in conditions that seem utterly inhospitable to us. Some fish generate their own light, others can change their sex, and some undertake epic migrations spanning thousands of miles. The sheer variety of survival strategies is astounding. This diversity is not accidental. It is the result of millions of years of natural selection, shaping each species to fit perfectly into its niche within the complex web of ocean life. The ocean is a living laboratory of evolution. Understanding these adaptations does more than just satisfy our curiosity. It helps us appreciate the delicate balance of marine ecosystems. Each fish, with its unique traits, plays a role in the health and functioning of its environment. The clownfish tends its anemone. The tuna controls populations of smaller fish. The flounder recycles nutrients on the seabed, and the anglerfish participates in the deep-sea food web. When these creatures and their habitats are threatened, the entire system can suffer. Protecting this incredible diversity is crucial for the well-being of the oceans and, ultimately, for our planet. The ocean's mysteries are far from fully unraveled. There is still so much to learn about the creatures that call it home, especially those in the deep, unexplored regions. Every new dive, every research expedition brings new discoveries and deepens our respect for the resilience and ingenuity of life. The adaptations of ocean fish, from the sun-drenched reefs to the lightless abyss, remind us of the vast, interconnected tapestry of life that our blue planet supports. They inspire us to continue exploring, to continue learning, and, most importantly, to continue protecting this precious underwater world for generations to come. The ocean's story is a story of life's endless creativity.